Welcome again in the module of cognitive system. In the first system we talked about the different process through which our cognitive information processing takes place, and in the first session we talked about sensation, perception, attention and memory. In the following session we will talk about now how we actually learn, how we think, solve problems, and when we solve problem, how quickly we do it, which is actually intelligence, and then finally how we think about our thinking, which is called metacognition. So the concepts that we are going to cover right now, after we have learned in the first part what is actually a cognitive system and what are the stages involved in the cognitive system, we have gone through how information is processed through acceptance of energy, which is called sensation, the interpretation of energy, which is perception, how we focus onto those information, which is attention, and then when we attend to something, how it gets stored into our system. After it is stored into our system, we need to understand how learning takes place. So in the first place I will tell you how learning takes place. After that I will tell you, while we learn we simultaneously think, because unless we think and solve problems we cannot learn. So how thinking and problem solving takes place, and then we will understand thereafter that when we solve problems, some people can solve it very quickly, some people fail to do it very quickly. It depends on the intelligence, that is speed of learning, so which we call as intelligence. And as I said, finally we will talk about metacognition, that is thinking about thinking, how we think. So we will start by learning. Now learning is an act of acquiring new information or modifying existing information. Some people say that we don't learn anything new which is absolutely never learned before, because some people believe that every new knowledge is an extension of old knowledge. It means we have acquired certain input already, and if that input or information is modified with the existing knowledge, if we modify our behavior based on that and skill, then we synthesize different information in order to learn something differently. So learning therefore is an act of acquiring new information or modified existing information. This learning, whenever it takes place, it brings a change into our behavior or mental state. It is a relatively permanent change. If we completely forget what we have learned, probably that change is not apparent, but most of the learning brings some kind of change in our behavior or mental state. This learning may take place consciously or unconsciously. We believe that we have been learning everything consciously, but actually many a time we learn things unconsciously as well. Many things we reflectively think inside, about which we are not consciously aware of, that also gets into our learning process. And then there are two kinds of learning in general. One is called associative learning, other is called non-associative learning. Associative learning is when two or more stimulus we connect it in order to get a response, that is two stimuli get connected, two apparently different issues get connected, and that brings a particular response. The association between stimulus and response actually is called associative learning. The non-associative learning is something where changes in response to a single stimulus over time, that is same stimulus is actually bringing different kinds of responses. It is not bringing identical response, it is called non-associative learning. So learning has got actually several theories. I mean, over the ages in past 100 years, several theoreticians have actually come up with different notions that how do we learn. Let us try to understand 4 or 5 different approaches in theoretical positions that tells us how we learn. Now, the first and the foremost theory that we have in man is Ivan Petrovich Pavlov, his theory of conditioning, learning by conditioning. Now, Ivan Petrovich Pavlov actually has done an experiment on dog, where he actually found that if the food is associated with a bell, the dog after certain reinforcement starts salivating, not even by looking at the food, only by the bell itself the dog starts salivating. That is, the food and the bell, when they are associated, it brings a different response. So, response to a stimulus is changed by reinforcing an association between stimulus and a behavior, which is called classical conditioning or learning by conditioning. We just now heard about associative learning. This is purely a form of associative learning. We associate between two stimuli in order to bring a change in our behavior. The second theory is by Thorndike's theory, learning by trial and error. That is, we all have understood that in order to learn something, we make several attempts. We make repeated attempts, varied attempts in order to solve a problem till we succeed. So, through trial and error, if we learn something, that behavior gets cemented, and Thorndike did experiment on cat. He found that if there is a food outside the cage, and if the cat has to come out by clicking a particular switch or by unlocking a particular latch, the cat actually tries several times and then succeed at some point of time. If it succeeds, that behavior gets cemented into our learning process. That is called learning by trial and error. You try several times, you make several errors, and then you succeed. Then comes the theory by Kohler. The Kohler's learning by insight. Kohler says that we learn just not by trial and error. We develop actually some kind of insight. We realize a problem solution like a reaction, I got it. So, that Kohler's learning by insight is a theory which is also called the Gestalt theory, because there are 3 psychologists or neurologists who are involved in Gestalt school called Kafka, Kohler and Wertheimer. They actually founded this theory, and they said that when you see a certain situation holistically, you find out a solution just by sudden realization. And Kohler did this experiment on chimpanzees. He found that chimpanzees were actually looking at certain bananas which it cannot catch hold of. So, after looking at the entire environment, the experiment suggests that chimpanzees suddenly realized that if the 2 boxes can be put atop, then the bananas can be reached. So, the whole realization came up after looking at the surrounding. It did not just make trial and error in order to get the bananas, because it would have never got it, because it is beyond its reach. So, Kohler's theory is sudden realization of a problem solution called learning by insight. Then we have got a theory of Bandura's social learning. Bandura says that we learn looking at others by observation, by imitating. We imitate others, how others have been doing, and then we learn accordingly. And then finally, we have a theory of Kolb's experiential learning. Kolb says that your practical experience or hands-on experience with a particular situation helps you learn much better. So, we find there are 5 different theoretical positions. Probably each of these theories are very important for all of us in order to learn something, but each one of these theoretical position has got certain value. Pavlov's value is that by conditioning, that is how two stimuli can be associated in order to bring a new change in behavior. Thorndike's theory suggests that we need to make repeated trial and make mistakes, and then only we learn that how success can come up. Kohler's theory is important, that it tells about the insight or sudden realization. If you do not look at beyond the problem situation, that is, unless you see the context, the surrounding inside this problem, you would not be able to get that solution. So, that insight development is very important. Bandura's case is about social learning, how you look at others and learn through them, like all of us learn through our parents, mothers and fathers. And the Kolb's experiential learning suggests that you learn through your experience only. That is what is the different theoretical positions. Now, there are three approaches to understanding learning. One is called behaviorism, one is called cognitivism, one is constructivism. In the next slide, we will try to learn about that. Now, behaviorism suggests like associative learning, classical conditioning theory like, says that learner is a passive object, element. It is a blank slate, and we learn everything through external process. Like if I have to learn, I have to listen to lectures, I have to go for rote learning, I have to go for practice, everything we will learn. So, through external process only we learn. That is a behavioristic approach. A cognitive approach suggests that learning is an internal process, which is against the behavioristic approach. The cognitive theory suggests that learning builds their understanding of their thinking process to generate new ideas. As I told you in the earlier module, that learning and understanding are two different things. When we understand the whole process. We just do not understand or learn the particular content. We understand the whole process. So, visual tools, when you think aloud, when you discuss, when you brainstorm, everything will help us learn much better. That is a cognitive theory which says in a holistic manner how we can learn better. The constructivism says that you learn through personal experiences, the experiential theory. We just learned about the Kolb's social experience and the Bandura's theory. We build on our personal experience, social experience. So, when we work in a group, when we discuss amongst ourselves, when we go for self-guided learning process, it actually helps us construct in a different manner. Your learning becomes transformative in a better manner. In cognitive theory, learning is exclusively an internal process, but in constructivism, the learning is more on a personal experience where there are collaborative projects, self-guided learning process. So, since we have now learned what is learning, it is important for us that during learning what happens, that is thinking and problem solving. Let us try to understand what is thinking and problem solving. Now, thinking is the ability to analyze and evaluate and synthesize information. You have to arrive at a decision, because when you have learned something, you have to arrive at a decision, you have to create new ideas. So, you have to analyze, evaluate and synthesize information, like questioning assumption. When you get an answer, you can question an answer, you can look into different perspectives, you can assess the validity argument of what somebody is saying. So, thinking is a search engine kind of thing, where whatever you have learned, you question it, you try to question those assumptions which are already accepted. Some people never question accepted assumptions. Some people are more reflective, they are not reflexive. Reflexive people learn and forget. They retrieve whatever information they have acquired. But those who are reflective people, they continuously think, they challenge the assumptions, and through that process they try to generate potential solution of a problem which is not inherent within the problem. So, learning can be deductive, learning could be inductive. The deductive means when the solution of a problem is inherent within the problem. The inductive learning is something which is like a problem solving for a new problem, that is not having a solution within the problem, you have to go beyond the problem in order to find out a solution. So, problem solving is a process of generating potential solutions and implementing effective strategies for that. There are two kinds of thinking. One is called divergent thinking, one is called convergent thinking. In the following slide, we will try to understand why these two kinds of thinking are so important for us, why they are complementary to each other. They are not compatible or comparable, but they are complementary to each other. Let us try to understand what is divergent and convergent thinking. Now, divergent thinking is a process in which you generate many possibilities without having a judgment. So, when you learn something, you actually do not try to understand what is there within the solution. You try to expand your thought process with more and more possible solutions, ideas to a problem. In that way, you become very creative, and that creative solution comes out of your divergent thinking. The divergent thinking does not mean you are getting a optimal solution. Divergent thinking is something where you actually look into the range of possible solutions, and instead of trying to arriving at a decision or a solution, you will look into a problem with 10 different options. If there is a problem and if you find out 5 different solutions, you can always tell which one is the best or which one is the good or which one is the right kind of solution. That actually we try to understand in our convergent thinking. Now, in convergent thinking, we try to refine those possibilities in a singular actionable outcome. Divergent thinking, you remain at a floating state in your thinking. When you learn a particular chapter, when you try to solve a problem, you come out with a number of solutions. So, you are floating, you are still not arriving at a solution. But when you come to a convergent solution or a convergent thinking, you find out an optimal solution. If there are 5 solutions available, which one is the best solution? So, these two thinking process help us think in a much better way through a complementary mechanism. That is, the strength of the divergent thinking is the weakness of the convergent thinking, and the strength of the convergent thinking is the weakness of the divergent thinking. So, if they function in a complementary manner and if you think in that process, you will learn much better. Now, the whole learning process also requires some kind of speed, and that speed is actually defined by a process called intelligence. In the following slide, we will learn about intelligence. Now, intelligence is a process which has got 3 major components. One component is the ability to deal with abstract concepts, that is, you can deal with symbols, you can visualize a solution which you are not seeing physically. So, ability to deal with abstract concepts, ability to learn from experience, we have just learnt about it, the experiential learning, and ability to adapt to a new situation and deal effectively with the environment. These are the 3 components of intelligence. There are multiple definitions of intelligence, maybe over 500, and if you try to combine them, you will find these are the 3 elements which are coming into intelligence. Now, intelligence as a subject matter has been of some interest for the last 120 years. Ever since 1904, the notion of intelligence has been coming, and people have been trying to measure intelligence through certain procedure which is called psychometric paradigm. In the following slide, we will try to understand what are the different ways the psychometric paradigm is trying to understand what intelligence is all about. There are 3 major paradigms. The first paradigm suggests that we have got one single underlying general mental ability common to all cognitive tasks. Any task that you do, only one particular engine in the brain, which is a G factor, is responsible for it. And Spearman is a person, he actually devised a statistical method called factor analysis, through which he says that the G that you see in the middle of it, the G factor is the general factor is important. Any person who is intelligent has got a good G, and if he has got a good singular that strength in ability, he or she would be able to perform all kinds of tasks. The second theory comes, which is the theory proposed by Thurston called primary mental theory ability. Thurston objected to this G theory, and he suggested that there are 7 factors, there are 7 independent factors, which is also understood through a statistical process called factor analysis, through which we actually understand or solve a problem. These are called primary mental abilities, like as you can see in this slide, the perceptual speed, the visual relationship, the memory, the induction, the word fluency. These are the different factors which are coming. The space, I mean how you look something in a virtual space, or how you can rotate a particular object in a virtual manner, I mean in a spatial relationship, is something which is Thurston has been saying is very elementary to human intelligence. So, he proposed, Thurston proposed about 7 independent factors, not one single general ability. And then comes triarchic theory of Sternberg. Sternberg says that 3 distinct components of intelligence: analytical, creative and practical. 3 different distinct components, he says: analytical ability, the creative ability and the practical ability. The creative ability is something which is imaginative and innovative problem solving. The academic or the analytical intelligence is mostly required in our academic performance, and practical intelligence is required in our day-to-day activity. Now, these are the psychometric paradigms, but there are different theories of intelligence as well. The theories of intelligence, they suggest that there are 2 major theories. One is called crystal and fluid intelligence by R.B. Cattle. Cattle says that, well, there are 2 different kinds of intelligence. One is called crystal intelligence, other is called fluid intelligence. The crystal intelligence is stored knowledge which you can recall as and when needed. That is what is called crystallized intelligence. You have already stored into a long term memory. Whenever that is required, you actually get into that. But the fluid intelligence is your ability to learn, assess and navigate a new situation. Something which is not stored into your system, you can still navigate it, you can still find a solution for that, which is called fluid intelligence. So, Cattle talked about crystal and fluid intelligence. The most recent theory suggests of something which is a common feature amongst all theories that we have just learned, is called hierarchical theory by Carroll. Hierarchical theory of Carroll says that, well, there are 3 levels of intelligence. In the top level, we have got a general ability, a single general intelligence like the G factor, and then we have got broad ability, which Carroll says about crystallized and fluid intelligence, and then there is a narrow specific skill that make up our broad ability. So, in the figure itself, you can see we have got general ability, we have got broad ability and we have got specific abilities. These are the 3 domains he mentioned. On the top there is a general ability, which in the first domain you call crystal intelligence, and then you can domain 2 you can get the fluid intelligence, and third domain you actually get the narrow and specific skills that make up your broad abilities in total. So, these are the different intelligence theories. Intelligence is nothing but basically how quickly you process information. So, the strategies to improve learning is that you keep learning new things, learn in multiple ways, just not in one particular way. When you share your knowledge with others, you learn in a much better manner, because sharing is caring. Not only, it also helps you learn better, you understand yourself better, you gain practical experience, you make mistakes, you use distributed practice. As I said, continuous learning is not good, and stop multitasking. So, at a cognitive level, your psychological investment is very important when you learn, At a behavioral level, your participation with others, as I said, share with others what you are learning, that helps you learn much better. And the emotional component, as I said, which is not studied within the cognitive domain, but that is also very important, that your intent, that is whether the matter is interesting to you or not, whether you are getting interest out of your knowledge gaining process or not, whether you are becoming creative or not, all these things come through your emotion or the intent, that is very important in our learning. Then we will learn about learning, which is called metacognition. So, in the following 2 slides we will learn about metacognition. So, metacognition is a process, is an act of observing and reflecting your own thoughts. That is, you think about your own thoughts, how you are thinking, because if we are thinking in a process about which we are not aware of, we will continuously think. If we are thinking in a wrong manner, we will continue to think in a wrong manner. So, it is very important that you plan your thought process, you monitor what you have been thinking, and you evaluate how you are thinking. So, when you plan it, you have to understand what are the important elements in the questions or in the task. When you study something, understand what is the core concept, what resources do you need to answer this question, and then you monitor itself, that what do you already know about this topic, can you relate this new knowledge as an extension of your old knowledge, how can I check that I am doing things right. So, you have to monitor yourself, and then finally you have to evaluate, what did I go wrong, why do I fail to remember it properly, why do I fail to catch up the basic concept behind it. So, why did I make the mistake that I did earlier? If you have to actually rewind yourself, you have to evaluate yourself. So, metacognition is actually cognition of your cognition, in which you will plan for yourself, you will monitor your own thought process, and you will evaluate. The whole process makes you a very reflective person to understand how you are actually thinking. Now, in the following slide, we will understand that if you have to understand what kind of thinking you are actually thinking, you need to understand whether you are a serial processor or a parallel processor. That is, when you think, how you actually arrange the things. Do you think those things in a serial manner, or do you think those things in a parallel manner? So, the metacognitive strategies come in this way. One is called as serial processing. Serial processing means you try to understand how you are learning, one after another, sequentially. So, our left brain is a very good sequential processor. It means one process must be completed before the next process starts. That is why those who are serial processor, they can perform their task very well. We have already said that if you try to distribute your attentional process, divide your attentional process by doing so many things at one go, that actually clutter your thought process. Parallel processor are somebody who can actually process it through parallel mechanism. That is, some or all processes involved in a cognitive task. The parallel processor, some people are very good. In parallel processing, you think not only serially, you also think parallelly, that is sequentially and holistically. Some of the tasks require both, and do not think that you have to actually adhere to one process, but one of these processes should take a center stage in our learning system. You have to understand you are a very good parallel processor or you are a very good serial processor, and this understanding about yourself is actually called metacognitive strategy. So, if you think this to this photograph, you will find that serial processor, well, there are so many dots at one go, but it is being processed one at a time. That is why, and then finally you come with an outcome. But a parallel processor, they get so many inputs at one go, and they actually try to process all at a time, and then they also come out with the outcome very close to serial processing. The outcome may be same, but the processing mechanism becomes different, and that is why you need to understand what kind of metacognitive strategy you have in hand. Finally, we need to understand that, well, how we can utilize those strategies in our learning. You question yourself, did I miss something? So, when you give exam in the examination, you recheck yourself. Should I check it again? Some people don't do that. Question yourself, did I do it rightly? Not too many times, but at least once or twice you must question yourself. Reflect. You pause to think about a task. Don't continuously try to think about a thing which you fail to solve. Pause at some point of time. How to improve the thought process next time. When you pause, you develop a new strategy to learn it, not in the same strategy. So, reflect on yourself. Develop awareness about your strengths and weaknesses. SWOT. SWOT means strength, weakness, opportunity and threat. Do it for yourself. What are your strengths? What are your weaknesses? What are the opportunities you have in hand? Who are there to help you out? And what are the threats? How quickly you have to learn all these things. So, your awareness about your strengths and weaknesses, you cannot have all the strengths, you cannot have all the weaknesses. You have all the combinations of strength, weakness, opportunity and threat. Then develop a learning style that visually you learn better, auditorily you learn better, analytically, holistically. I just talked about your serial processing and holistic processing, which is parallel processing. So, when you read something literature, a holistic processing works better, but when you are doing mathematics or physics, your analytical process works much better. Some people read things better through visual processing, some people through auditory processing. So, you have to understand about yourself. Think aloud, that is, make thought process explicit, that I am thinking about something. Is it okay? Is it okay for yourself? Don't ask somebody else. Or you can ask you can ask yourself, or you can ask somebody else that whether your thought process is correct or not. You go for active reading strategies, underline text, scan the main ideas, and then active listening strategy. When your teacher has been teaching, if you do not maintain your eye contact, if you don't nod, if you don't ask question, it will not be absorbed or processed the way it is supposed to. So, a metacognitive strategy in learning actually helps you learn much faster. You don't require very high level of intelligence always to actually learn something in a concrete manner. If you know how to think about your own thought process, how to cognize your own cognition, what are the issues, the strengths and weaknesses, what are your learning style, how you can reflect on your thought process, how you can question yourself, these things will help you learn finally much better. So, this is the different method or stages through which we have just discussed how we actually learn. So, we have got certain books and links through which you can understand how we can learn, but basically we have been talked about all those things that are written in these documents as well. So, with this